Hey everyone, how's it going? So, today we'll be learning about natural language processing and let's get started. So, what is natural language processing? It's just a fancy way of saying that computers are taught to understand and work with human beings, like English or any other language people use to communicate. So, NLP helps computers read, write, and talk to people in a way that makes sense, right? So, but why is NLP important? It is essential because it allows computers to communicate with humans in a way that feels natural. This is very important for many things we use every day, like voice assistants like Siri, Alexa, chatbots, or even translating languages. So NLP helps us search the internet, get recommendations on what to watch, and understand our emails better. It's like teaching computers to speak our language, making them more helpful and accessible. Then there are some NLP techniques that we'll see in later slides. So yeah, let's hop on to other slide. All right, let's walk through the journey of NLP's evolution. So, it started in early 1950s when computer scientists started working on basic processing tasks. The development of first language processing programs aimed at translating languages and processing text in a rudimentary way. It was based on rule-based system where human experts manually crafted linguistic rules to analyze and generate text. So then again in the 1980s to 1990s, statistical models began to gain prominence. Researchers started using probability and statistics to make NLP systems more data-driven. So this era saw the development of part of speech tagging and syntactic parsing using probabilistic models that we will get into later. And then in 2000, we saw deep learning revolution. We saw some rise of deep learning techniques, especially recurrent neural networks, RNN, and transformers. We had development of models like BERT, GPT, that led significant breakthroughs in NLP tasks such as language translation, text generation, and sentiment analysis. Large pre-trained language models like GPT-3 and BERT, which can understand and generate human-like text, have become central to many NLP applications. Yeah. So let's try to go towards demystifying natural language processing. We'll see how does it actually work, what does it involve, and what are the challenges NLP faces. And in the end, we'll see the applications of NLP where we can actually use it. And yeah, there are many applications, a lot of applications for NLP. Okay, let's get started. Alright, let's see what are the common NLP techniques used. So we have here tokenization, stemming and lemmatization, parts of speech tagging and syntax parsing, and named entity recognition. Let's see what are these. So what is tokenization? Tokenization is the process of breaking text into smaller units, and those smaller units are called tokens. So I'll give an example. Let's say I love eating pizza. So here, if I tokenize this sentence, it will break down into 4 different tokens. That is, I as one token, love as the second token, eating as the third token, and pizza as the fourth token. So that's how we tokenize text. Moving on to stemming and lemmatization. Stemming is reducing words to their base or root form by removing suffixes. For example, let's say there is jumping. If I want to stem this jumping word, it will be stem to jump. And similarly, if I want to stem jumps, it will be stem to jump. Okay, so here I remove the suffixes or even a prefix. You can even remove a prefix of a word and stem it to the base word. Now, what is lemmatization? Lemmatization might sound similar, but there is a difference, let me tell you. So, it reduces words to their base or dictionary form, considering the word's meaning, and that reduced form is called lemma. I'll give an example. Let's say good. The word good has three forms, that is good, better, and best. So if I come up with a word better and I want to lemmatize it, it will reduce the word better to good, to its base form. Similarly, let's take bad, worse, and worst. If I want to lemmatize worse, it will be lemmatized to bad, and the same thing will happen to worst. So that's how lemmatization works. Okay, now what is parts of speech tagging, also called POS tagging? So what does it do? It basically assigns grammatical labels to words in a sentence, indicating their role. For example, it can be a noun, it can be a verb, or it can be an adjective, right? So let me give an example. Let's say the cat sleeps peacefully. If I want to do POS tagging for this sentence, it'll be like they is an article, cat is a noun, sleeps is a verb, and peacefully is an adverb. So here we can see POS tagging has assigned all the grammatical labels to the words in the sentence. Okay, so we have another term here, syntax parsing. So it involves analyzing the grammatical structure of a sentence to understand how words relate to each other. For example, identifying subjects, objects, or modifiers. Say, for example, I have the sentence, the dog chased the cat. So if I want to do syntax parsing, it will reveal that the dog is the subject, right? Because the dog is chasing the cat, and the word chased is the verb, and the cat is the object, because here it's the cat that is being chased. So that's how syntax parsing works. Now, moving on to the last technique, that is named entity recognition. So it identifies and categorizes named entities in a text, such as names of people, places, organizations, dates, and a lot of other things. For example, I'll give you this example. Apple was founded by Steve Jobs on April 1st, 1976. Now, if I want to do the named entity recognition for this text, Apple is an organization, so Apple will be recognized as an organization. Then we had Steve Jobs in the sentence, it will be recognized as a person. Then we had a date in the sentence saying April 1, 1976, it will be recognized as a date. And similarly, in other sentences, you can also encounter location and few more other things. Okay, so that's the techniques we use in NLP. Alright, let's see what are the ambiguities in NLP. As the name suggests, it refers to the situations where the meaning of a sentence or a piece of a text is unclear or can be interpreted in multiple ways due to the inherent complexities of human language. These ambiguities pose significant challenges for NLP systems. So let's explore some common types of ambiguities in NLP. So we have mentioned three types of ambiguities in NLP here. They are lexical ambiguity, structural ambiguity, and referential ambiguity. Let's see what are these one by one, and I'll explain you these with examples too in the next slide. So, lexical ambiguity arises from words that have multiple meanings or senses, depending on the context. And structural ambiguity, it arises when a sentence can be parsed in more than one way, leading to different interpretations. Referential ambiguity, it occurs when a pronoun or reference in a sentence is unclear and it's challenging to determine what it refers to. So let's see with the help of examples what these ambiguities really mean. So here I have given an example of bank. So it can mean financial institution or the side of a river. When you say I am going to the bank, it can give two different meanings. Either you're going to the bank of a river or the financial institution from where you can take the money. As in the second example, I have mentioned bark. Bark can refer to the sound of a dog or the outer covering of a tree. So here, determining the correct meaning of a word based on the context is essential for accurate understanding. Moving on to syntactical ambiguity, I have given an example here that says, I saw the man with the telescope. So this sentence can be interpreted as I used a telescope to see the man, or it can be interpreted as I saw a man who had a telescope. So we're not sure which sentence it really means. Moving on to the second example, it says the chicken is ready to eat. So here we're again confused if the chicken is being served or the chicken itself is ready to eat. Now, there is referential ambiguity, that is the third type of ambiguity. Here, I have given an example saying John called Mark and he was angry. So it's not clear if he refers to John or Mark. Similarly, in the second example, the boy told his father that he was very upset. So here again, we are not sure if he refers to the boy or his father. So these are the type of ambiguities that we can encounter in NLP. In addition to the various types of ambiguities that NLP can face with, there are a few more challenges that the model can struggle with. For example, capturing nuanced meanings, humor, sarcasm, and cultural context remains a challenge. Many NLP tasks require extensive label data, and creating high-quality data sets can be time-consuming and expensive. NLP models can inadvertently leak sensitive information when generating text or handling user data. As NLP systems become more and more powerful, ethical considerations around misinformation, deepfakes, and manipulation of content becomes increasingly important. Now, let's see what are the techniques that can help us resolving the various ambiguities. The first one here is word sense disambiguation. It helps determining the correct sense or meaning of a word with multiple senses based on the context. For example, if I say the bank is by the river, this technique will identify the bank referring to a river bank, not a financial institution. Similarly, the other technique of co-reference resolution, it will help determining which words or phrases in the text refer to the same entity. If I say John called Mark and he was very angry, this technique will help me in resolving that he refers to the Mark. Okay, so there's another technique, say, by the name of contextual disambiguation. It helps disambiguate quantifiers like some, all, or many based on the quantity or extent indicated. For example, in some cats are black, context can reveal that the intended meaning of some. Similarly, we have one more technique of machine learning approaches. Machine learning models can be trained to disambiguate text by learning patterns from large datasets. For example, a supervised model can be trained to distinguish between different senses of a word based on label examples. So effective ambiguity resolution often involves a combination of these techniques. Modern NLP systems such as transformers use neural networks to leverage context and semantics for disambiguation, which leads to the significant improvements in language understanding and more accurate results in various NLP tasks. All right, let's see the various applications of natural language processing. In the domain of healthcare, NLP can help us convert spoken or handwritten clinical notes into structured electronic health records, which improves the efficiency of data entry for healthcare professionals. The main thing NLP can do is analyzing patient records and medical literature to aid in disease identification, prediction, and even early diagnosis. For example, it can assist in identifying patterns in radiology reports or analyzing electronic health records for disease trends. We can also have chatbots that are powered by NLP, and they can provide patients with information, appointment scheduling, and even symptom analysis. So one of the other things NLP can do is drug discovery. Yes, it can help with drug discovery. It can extract and analyze information from scientific literature to assist researchers in drug discovery and development. In the domain of finance, NLP is used to analyze new articles, social media, and financial reports to gauge market sentiment. This thing helps traders and investors make informed decisions. It can also help us identify fraudulent activities by analyzing transaction descriptions and detecting anomalies in financial data. And just like in healthcare, we can also have chatbots here in the finance sector, which can handle customer inquiries and transactions and enhancing customer service in the financial service sector overall. Moving to the e-commerce domain, NLP helps analyze customer reviews and product descriptions to provide personalized product recommendations to shoppers. E-commerce websites often employ chatbots and virtual assistants that are based on NLP models that assists customers with product searches, orders, and returns. NLP is also used to analyze customer reviews and feedback to understand customer sentiment and identify areas for improvement. So it can also help with the search enhancement. It can improve site search functionality by understanding natural language queries and returning relevant answers. So these are just a few examples of how NLP is applied in various industries. NLP continues to evolve and expand its capabilities, driving improvements in efficiency, customer service, decision making, and insights across different sectors. As we conclude our discussion on natural language processing today, let's reflect on the key takeaways. First, we delved into the challenges that NLP faces. We have seen how dealing with lexical ambiguity, acquiring high quality data, and ensuring context understanding remain ongoing hurdles. However, it's essential to remember that these challenges are not roadblocks, but rather stepping stones for innovation in NLP. Looking ahead, the future of NLP is incredibly promising. We can anticipate more powerful pre-trained models, improved cross-lingual capabilities, and a greater focus on interpretability and ethics. NLP will continue to redefine how we interact with technology and open up new horizons across various industries. Finally, the opportunities presented by NLP are vast and diverse, from personalized healthcare solutions to customer-centric marketing strategies, from more efficient legal search to seamless global communication. NLP has the potential to transform countless aspects of our lives. As we move forward, I encourage you all to stay curious and engaged in the field of NLP. Thank you for your attention, and let's continue to explore the exciting world of natural language processing together.